Video tour of my station. Set up here for 2 meters through 3456 most of the time, but some of the antennas are down on the roof where the range is kind of limited. Okay, these are the two main HF rigs here. I've got a TS940 and also a TS430, and they're both running through this switch matrix, which allows me to use these two HF rigs as the IF for a bunch of the transverters. All the bands convert down to 2 meters and then on down to 28 megahertz as an IF. And then I've got a 2 meter rig, ICOM 271A, azimuth and elevation rotors for the antennas, an NIR10 for the digital signal processing. It reduces the noise. It's hooked directly into the audio coming out of the TS940. And then for packet I've got PK232 and also a Cantronics TNC. Don't have the computer sitting here. Normally there'd be a monitor sitting on the side of the console here, and a small 386 computer that's just dedicated to packet. Okay, looking at this switching console here to give you some idea what goes on. I have push buttons that allow me to select 6 meter, 2 meters, or 220 or 432, and convert from those bands down into the 210 meter rigs. And I can push buttons and switch back and forth between the 430 and the 940. 940's got a much better receiver, and so I can hear a little bit better using it. And so most of the time the 940 stays on 432, but if there's something that I'm having trouble hearing on, say, 220 sideband, I can push a button up there and switch it in line with the 940 and the digital signal processing. Right now we're listening to a beacon up in Virginia. I'll bring that up on the speaker here. It's the W4VHH beacon in FM07. It's on the mountaintop where the Four Landers contest group has gone for the last 2 years. This is a 10-watt signal from about 350 miles out, 10 watts to an omnidirectional antenna up near Covington, Virginia. What we're looking at on screen here is the fast Fourier transform of the audio coming out of the TS940 after it's already been digital signal processed in the NIR10. And we can see quite a few crossing traces of airplanes in the path between here and Covington, Virginia. And a few of the straight lines that are in there are just 60 hertz harmonics that are hard to keep out of the FFT. You can hear the ID now. very weak today. This is probably the way I hear the beacon all the time. Right now it's 4 o'clock in the afternoon, so it's one of the worst times for the propagation between here and there. You can hear the ID pretty well, but it's not extremely copyable. And just yesterday morning, I guess it was, the beacon was S9 compared to S1 or something right now. And the transverter gain is what makes the S meter reading be above 0. In other words, there's 30 dB or 50 dB counting the preamp gain driving into the HF rig. That's why it's up off 0. Okay, I have a second switching console here, which takes a 2 meter transverter and uses it to drive some of the microwave bands. I've got 1296 homebrew transverter. Puts out about 10 or 12 watts, and that drives into this water-cooled pair of 7289 tubes, which puts out about 125 to 200 watts depending on how the tubes are, whether they're old tubes or new. And then in the other side of this, there's a 2304 power amp that I'm still working on getting hooked into the water cooling and the power supply system. And by pushing another button, I can switch from 1296 to 903. Puts out about 8 watts. It's not real linear. It's got a cellular Class C power amplifier in it. Homebrew transverter again. And if I push another button, I can switch over to 2304. And this unit puts out about 7 or 8 watts also. And up on the roof, I'd have a 4-foot dish with 2304, 3456, and 5760 in a tri-band printed circuit board type feed on the 4-foot dish. And then for 903, a loop Yagi with 33 elements. 432, I've got 4 22 element K1FO antennas. And then on 1296, I've got a 45 element loop Yagi there. And for 220, I've got a microwave modules transverter. 6 meters is also a microwave modules transverter. I don't have an antenna up for that at the moment. And for power on 220, use this surplus AM6155 that's been modified to work better at 220. Puts out about 400 watts. And then this power amplifier, which is a pair of 8930s that is for 432, puts out about 800 to 850 watts.
done?
Yeah, it's narrow bed. Well, it's pretty important.
Using that transceiver as a source.
Everything is sandwiched between those two boards. OJK's the one that built that one. And then just using the 2-meter IF. And you can see the output, the relay.
They got those NMICs?
Do what?
There's NMICs?
Yeah.
What's the front end transistor?
ATF 10. Yes, gas fed. ATF 10, 15, or you know those numbers. What I cut it out on a piece of cardboard and had all the dimensions out and then on the board looking on it. Well, I'm not going to change it. I'm going to splice it. It's calculated to be 25 dB, and I measured it 24. Real hard getting that, that's a weak spot, so get that out. Broke it twice just putting them together, which kind of messed up my transition from the waveguide to the... Charles, remember that? You remember getting those things, what, 15 years ago? Mitsubishi. And I don't know what it runs, about probably 20, 30 milliwatt.
If that much, I think it's more like 10 milliwatt.
Yeah. I just little gun punch.
It's a dielectric resonator.
I used to take that thing and got a battery pack and sit there like that. And this also works good for radar. Oh yeah. I see everybody put their brake. Right, I carried it in the company vehicle for a couple of years. Every once in a while somebody...
Have to get some more, I guess, from Canberra.
Okay, got JQV here. He's what stood in front of the antenna. It made him look strange. Charles came back and he's running video here. Boy, when he first came on, if I point that thing toward that Cadillac over there, the signal gets a lot stronger. I guess it does some enhancement to it. But you're still S9, but if I move the antenna around, of course you'll hit 20 over 9 go.
Okay, well, it's, I mean, it's not exactly DX, but it's fun. It's interesting. I wish we were about 5 miles apart. I think we probably have to have the antennas more sighted on each other a little bit more. And I hear an airplane. If that plane flies over the flea market, we'll both point at him and see what happens. That might be an interesting experiment. Anyway, you say,
Oh yeah, that helps, yeah. Let's see, why don't you tell me which bands are which over here on the console.
Well, this top module here is for 3456 and 2304, and the bottom one is for 2 meters, 432, and 1296.
Everything transfers down into your 940.
Transfers down into the 28 megahertz with the 930. This over here is power amp for 2304 and 34 and 1296.
How much power do you think you'll get out of that?
1296 is about 200 watts, and 50 watts out from the 2304, and then this is just a common power supply for
both amplifiers.
So something about your switching arrangement back here on top, 4-way.
Okay. This switch here handles the all of the receiving from 432, all the antennas from 432 up to 3456, and then this switch here handles the transmitter, and the switches are controlled by the band switches on the two transverters here. Over there is a plate that all of the controls and the antenna connections come through the wall, and I've got two boxes here. The first one on the floor contains a switch that allows me to switch the main transmission line between 2 meters, 432 and 1296, and actually the 1296 position I've got coming out and coming into this second box that contains switching that allows me to go from 1296 up through 3456. It's built-in LNAs for each of the bands in both boxes.
And so you got 3456 there.
Yeah, this is a 3456 loop antenna, and just got that one 432 volume. In fact, I've got the cover off of this box over here if you want to see the relays and the controls and LNAs, what have you.